We're here. Okay, we're back for the last section in the chapter.
Okay.
Miss Moach is going to start you out.
Hi, everybody. Today we're going to go on a little bit different direction, still working on circles, but only more algebraically. We're going to work on equations of circles. So, that didn't work. There, okay. We can graph circles in a coordinate plane. And what does the equation of a circle even look like? Let's figure that out. If you look at the drawing, you can see that we have drawn a circle and it's centered at point HK. And we've picked a point on the circle, point XY. We made a little triangle there to show you something. If you look at where you're starting on that triangle at the center and you move to the right, where the right angle is, how far have you traveled? You have traveled X minus H, because the X coordinate directly under XY is X, and the X coordinate where it started was H, so it's X minus H. Here it is. Going from the right side of that triangle, where the right angle is, going up, we're traveling from a Y coordinate of K up to a Y coordinate of Y. So the length of that little segment is going to be Y minus K. And so now we have a right triangle. The hypotenuse is the radius of the circle. We know that when we have a right triangle, we can always use the Pythagorean theorem. So if you look at this particular triangle, the segment on the bottom has length X minus H. That's the first of the two legs. So we write X minus H squared, because it's always leg squared plus leg squared equals hypotenuse squared. So the first one is X minus H squared. Likewise, the second leg in the Pythagorean theorem will be Y minus K squared, and that will equal the hypotenuse squared, which is our radius squared. There we go. We just figured out where the standard equation of a circle came from. It came from the Pythagorean theorem simply used on a circle with a center and a radius. And so every time you see an equation in this form, you know that if you have X minus H squared plus Y minus K squared equals a number squared, you know that the HK is the center of the circle and the R is the radius of the circle. So, you want to try the next one? Go ahead.
So when we look at example 1, problem A, we're looking for the center of the circle, and doesn't seem to be a point that is there. Oh, there it is. Okay. So we put the point at 2, 2. Then we know that we're going to write our equation of the circle, X minus 2 quantity squared plus Y minus 2 quantity squared equals, we have to find that radius. So that we can count down, so we can maybe just use the line that would go from the center vertically down, and we can see that that would be 4 units, so R squared 16. All right, there we have our equation.
Awesome. Thanks, Mick. Thanks, Moach. So in B, we're going to look at that, and we're really going to do the same thing. So I want you guys to take a moment on your own to see if you can get that equation. And then I'll chime back in. All right. So the center, hopefully you got as negative 2, 2. And then you counted the radius from the center, either right or left or up or down. And it looks like it's 3 units. So you got your center as negative 2, 2. You got your radius as 3. So when you plug it into the equation, remember x minus a negative becomes x plus, because it's x minus negative 2. So x plus 2, quantity squared, plus y minus 2, quantity squared equals r squared. 3 squared is 9. All right, so these are pretty easy problems, I believe. All right.
Okay, these next two problems are going to be for you to try. Now that you've seen the standard form of the equation of each circle, we are simply going to give you a center and a radius for two different circles. And can you please try to do both of those problems? See if you can get the equation of your circle in standard form.
Okay, for example A, we have a center of -3, -2. So we're going to substitute those values into our equation. It's going to be x minus -3. So that's really going to be x plus 3 quantity squared plus the quantity y minus -2, which we were just going to write as y plus 2 quantity squared equals 3 squared, which is 9.
All right. And in B, maybe the 0 confused you, but x minus 0 is just x, right? So it's just x squared. Now, it wouldn't be wrong to write x minus 0 squared. And then it's y minus 5 squared. And then you've got to remember how to square a fraction. So when you square 1/2, you square the numerator and then the denominator. So it's going to be 1 squared is 1 and 2 squared is 4. So it equals 1/4. So you got x squared plus y minus 5 quantity squared equals 1/4.
Okay, now as usual, as we go through our examples, they get a little bit harder as we move along. And so now we're going to give you a little bit different information. We're telling you what the center of the circle is. It's 1/4. But we're not going to give you the radius, with the center at 1/4 passing through the point 4, 1. So we just have 2 points. We have the center and 1 point on the circle. So we can start to write the equation of the line. We can do the x minus 1 quantity squared plus y minus 4 quantity squared equals the radius squared. But we don't know the radius yet. However, we do know that the point 4, 1 is on this circle. So we can plug that point in for x and y, and that will allow us to solve for the radius. So we're going to have 4 minus 1 squared plus 1 minus 4 squared equals r squared.
And so I just want to interject that 4, 1, that's one possible x, y coordinate. There's many, but that's one possible x, y coordinate. And so you can see that this is the x. Oops, sorry. This is the x, and that's the y. There we go. Okay, finish it up for us, Moch.
Okay, so 4 minus 1 squared is 3 squared, which is 9. And 1 minus 4 is -3 squared, which is also 9. So we've got 9 plus 9 equals 18, meaning that r squared is 18. Okay, we want to also graph this equation, so we kind of have to have an idea of what r is. So we will jot down the square root of 18 is 3√2. But now to actually write the equation, we go back and just substitute our r squared value in. X minus 1 squared plus y minus 4 squared equals 18. So now, in order to complete the graph, we start by drawing the center of the circle, just a point. So we draw the point 1,4. And then we have to kind of approximate how long r is. It's 3√2, square root 18. Well, that's going to be somewhere between 4 and 5, probably closer to 4. So we made our radius just a little tiny bit larger than 4. This does not have to be precise, folks. Okay? So to graph a circle, you go for your radius, you go 4 plus a little to the right, up, to the left, and down, and then you try to connect them with a nice circle. We're lucky because this piece of software makes our circles look really good. When we draw them on our own, ours don't look that great either.
Or you could use a compass.
Yes.
Definitely mine don't look that good. My
Yeah.
students know that. I just want to go back to where we got the between 4 and 5, because I want to make sure that everybody's clear on that. So if we have the square root of 18 and we're not using a calculator, we want to think about our perfect squares. And we think of perfect squares that we know of. 4 squared is 16 and 5 squared is 25. And because 18 is between 16 and 25, we know that the square root of 18 is going to be between 4 and 5.
Awesome. Thanks for explaining that,
Yeah,
Mick.
that helps.
That helps a lot. Okay, so this next problem, example 4, is the same type of problem. So we would like to give you a little bit of time to work through it. It's going to take a little longer than some of the other problems you've done in this section. So, you might not finish it before we start explaining it, but try and see if you can follow what Miss Moach started with in the last example. Look back at it and see if you can figure out what would be the first step. So maybe you got your first step knowing that the center is -4, -3. You're able to plug in the center into the equation. Again, x minus -4 is x plus, and so on. So hopefully you got to that step.
Now try the second step.
Yeah. I put a little hint up there for you. All right, so hopefully you were able to figure out that that's one of the possible points on the circle. So it's one possible xy. There's an infinite number of xy's, but that's one of the possible xy's. So we plugged it in here. Just giving you a little time to figure out what r squared is on your own first. Hopefully you're there. R squared is 5. So this is another problem where it's not a perfect square. So the square root of 5, well, we can write the equation because we really just need to know r squared for the equation. So we can go back to step 1 and basically rewrite step 1, except instead of r squared, we put in 5. But like Miss Mix said, if we're going to figure out what the actual radius is to graph the circle, we need to know roughly what the square root of 5 is. And since 4 is a perfect square and 9 is a perfect square, and the square root of 4 is 2 and the square root of 9 is 3, the number is between 2 and 3, but closer to 2 because 5 is closer to 4 and 5 is to 9. So I moved up and down, right and left, 2.2. And you could take a calculator and get the exact value of the square root of 5.
The decimal form, yeah.
Yeah, the decimal. Yeah, it doesn't give you exact. It gives you a decimal with a bunch of decimal places. All right, so you got the circle there. All right, the next one is, remember the last section? We completed the square on a quadratic because we couldn't factor it. Well, here, you have to know how to complete the square. So we're going to rewrite this circle because in this form, we can't figure out what the center is and the radius is. So we've got to rewrite it to be in the form of x minus h squared plus y minus k squared equals r squared. And in order to do that, we're going to gather all the x's together. So the x squared and the x term together. And we're going to gather the y squared and the y term together. And we're going to bring that linear term, 6, we're going to bring that, or the constant, over to the other side. And also, I'm going to put little blank spaces after the x and after the y. And I'm also going to put blank spaces on the other side because we're going to add numbers to the left side of the equation, but in order to keep it balanced, we have to add it to the other side of the equation. And so we're going to do what I said last time. We're going to take that b value, which in this case is your -2 and your 6. And what we're going to do is we're going to take half of -2, which is -1, and we're going to square -1, which gives you +1. So we're going to add that to both sides. Then we're going to take +6, and we're going to take half of it, and then which is half 3, and then we're going to square it, which is 9. So that's what we're going to do. And we have to add those to the other side. Now, I want to factor each of these terms. So I want to factor this right here, and I want to factor that right there. And so you can just use your factoring, so what two numbers multiply to 1 and add to -2, or we can remember that we added that 1 to make it a perfect square. And so a perfect square is x minus or plus a number quantity squared. And so in this case, it's always just x minus half of b squared, and the other one's x plus half of b squared. because your b in the first one is negative and your b in the second one is positive. And then, where did I get the 16 from? Well, I just added the 6 plus 1 plus 9. And so, Moch, what's the center?
Okay, when you look at this, you can see that you are subtracting 1 from from x rather, so that's your h of your center. That's the x coordinate of your center. And then when you look at y plus 3, you remember, you have to have y minus k. So what number are you subtracting from y? You're actually subtracting a negative 3 in order to get y plus 3. So your k is negative 3. So your center will be 1, negative 3. And your radius is just the square root of 16, 4.
Awesome. And then we've been graphing these all day, so I think you can figure out the graph.
Very nice.
All right. Great job.
Now we're going to have you practice doing one yourself.
Yeah. Okay, we know it's going to take a while, like I said.
So you should be putting your terms in order and making some blank spaces and getting ready to complete the square, identifying your b values for your linear terms, thinking about that b value and then getting ready to divide it by 2 and squaring it.
So is this where they should be, Mick?
I think at this point, yep, everybody's there.
Okay, so we've put the terms in the places we want them. Now complete the square.
Is that right, Moch?
Yeah, half of negative 8 is negative 4, and when you square it, you get 16. Make sure you add it to both sides.
I'm going to be remembering that negative 4 so that when I have to write the equation in the next line, I don't have to do the work again.
Yes. And I'm going to remember that 3.
Yes.
Because I squared the 3 on the 6. I cut it in half and squared it. It got 9. I'm gonna remember the 3.
Okay.
So then Mick remembered that. So what does she factor the x one?
It's going to be x minus negative 4, which is really x plus,
x minus 4.
It's x minus 4 squared.
Mm-hmm. And y plus 3 squared, and that's going to be 16. So now that we have the equation, we can certainly see what is the center of the circle and what is its radius. So the center is going to be 4, negative 3, and the radius is 4. So we can go ahead, graph that center, and then count up, down, right, and left 4 units, and you will have a lovely circle.
Awesome. It falls off the page a little. Okay. Writing a coordinate proof involving a circle. So we're not going to do an official coordinate proof here. What we're going to do is it says prove or disprove that the point 3, root 7 lies on the circle centered at the origin. So if it's centered at the origin, what's h and k?
Well, that's easy. 0, 0.
Okay, so that's good. So we got that covered. So what I'm going to do is I'm going to plot the point 1, 4. And I'm going to look at that little right triangle because the radius comes from the center. And so what is the horizontal leg, Mick? What's the length of that horizontal leg?
just 1 unit.
It's just 1 unit. And the length of the vertical leg is?
It's going to be 4 units.
In 4 units. So then we can figure out what the radius is. So you could use the Pythagorean theorem to do that. So the radius is the square root of 17, and the center is 0, 0. So we know the equation of the circle is x squared plus y squared equals 17. Because remember, you got to square the square root of 17. And then we're going to see if 3 root 7 is on the circle. How do we do that?
We can just plug in the numbers. We can substitute 3 for x and root 7 for y and see whether or not it fits that equation properly.
And remember, when you square a square root, it's just the number underneath.
Oh, looks like they're not equal. What does that tell you?
So that means that the point 3 square root of 7 is not going to lie on the circle with radius square root of 17.
Okay, so the next problem, you might want to take out a larger piece of graph paper for the next problem. I didn't graph it on that little teeny graph because it doesn't fit. So on the next page, I actually graph them. And you don't have to necessarily write the equations. You could just go straight to graphing. So if you take out a larger piece of graph paper, then you should be able to graph it.
You want to do a good job with your graphs, so if you have a compass, it would be useful to use it.
Yes.
If you don't, just do the best you can.
Yes. And so I'm just, for practice purposes, I'm going to write the equations. So if you have the epicenter of an earthquake is 10 miles from -1, -3, so I can create an equation to a circle. And that one we've been learning all lesson, so hopefully you don't have a problem with that. So there's your equation. And then 2 miles away from 5-3, that's another circle. And then 5 miles away from 2-9 is our third circle. So you can see with radius 10, 2, and 5, and the centers at these places, it falls way off that little teeny graph I provided for you guys. So what I'm going to do is I'm going to get out a bigger piece of graph paper. So hopefully at this point in time, you guys snagged a piece of graph paper, and you could try and practice doing this. And if you happen to have a compass, that'd be really great because it'd be a great practice. So if you had this problem, you would actually use the tools in order to find it. So I plotted one circle.
Remember, all you really need to plot the circle is the center and the radius.
Right, so I didn't really need the equation, but I did it anyway. So I got those two circles. Those were the first two I drew. And you can see how it never would have fit on that little teeny graph. And then there's your third circle. So where they all intersect. Now again, my circles aren't quite perfect, but that's the point where they all intersect. And I don't think I wrote down that ordered pair, but what does that ordered pair look like? It looks like it's
Looks like 5-5 to
5,
me.
5, 5. So, I don't know. Did I write it down? Oh, I did. About 5, 5. So I did write it down.
These answers will be approximate because it is very difficult to make your graphs perfect. But the place where they all intersect is going to be where that earthquake started from.
Right.
Okay? That's the epicenter of the earthquake, and it sends out its waves.
Yeah. And you'd have a much easier time finding that approximate ordered pair if you used a compass. So you just put your pointer on the center and go however much the radius is and make your circles.
Yeah, fortunately they were whole numbers, so it wouldn't be that bad if you had a compass.
Right, exactly. You'd be able to get it really pretty close. All right, thank you guys. So we've wrapped up chapter 10, and there'll be worksheets and review sheets posted. There's big ideas, homework for you for this section. And then the next class, there won't be a lecture. It'll just be some worksheets and some fun, like networking, practicing, finding different things in a circle. And all of those are on the spreadsheet, the link that's on School Loop that I sent you in the email. And you can print up blank versions, and then you can look at the keys, and it's practice for you.
Okay, and I just wanted to add that we hope that you are all doing well, that you've managed to stay healthy by staying at home, and hopefully this won't have to last too long, but also enjoy your spring break.
Yeah, and just let us know if you need anything. We're going to be available during school hours, so email us, let us know if we can help support you in any way. We're here for you.
Yeah, and I want to say take care. And this is the end of the 2 weeks off, and then you have your spring break. So we really do want you to enjoy your spring break. So take care and be healthy.